So here we are again looking at an example of a cumulative frequency distribution from the class data. And so I'm going to pull up this table again that shows the answers to the feelings about math question. And our first column is our frequency. Our second column is going to be our cumulative frequency. And if you double check on there, you can see that you get the same diagonal addition to get the pattern of results, and then also talk about how to interpret them. So in your first cumulative frequency there, the number is at 3, which means that on a scale of how much do you hate math from least to most, 3 people would say, I love it, oh boy, and that's how much they hate math. That's how many people hate math that much or less. And in this case, you can't hate math any less than that on this scale, so it's going to be equal to the same number we have for frequency. All right, so our next value is I like it, I guess, and the cumulative frequency for this value will tell you how many people hate math at I like it, I guess, or less on the hate math scale. In other words, how many people would say I love it, oh boy, or I like it, I guess. And in the class data, that was 10 people. And you can keep going on like that down the line. So for I'm not a fan, but I'll do it if I have to, the cumulative frequency tells you on the hating math scale how many people were at that value or less hatred of math. In other words, how many people are at I'm not a fan, it's okay, I like it, I guess, or I love it. And there the number is 37. So in the class, 37 people were at that hatred of math or less hatred of math. You can also double check there. The first value in your cumulative frequency is equal to the first frequency, so 3 and 3. The last cumulative frequency is equal to your total number of cases, so 47 and 47. And then I've also shown the percent, which gives you the same information, but here it's percent. I'm not going to walk through every single number again, but you can also double check there. The first value in the cumulative frequency column is 6%, which is the percent for I love it, oh boy. And the last value in the cumulative frequency column is 100%, which is the total percentage of cases that are in the sample. So it includes 100% of people's responses. All right, so frequency distributions are here to help us organize data. But what happens when you have a whole lot of values that a variable can take on? Suddenly, this frequency distribution has a lot more to look at, and it's not really as helpful in organizing the data that we have. And so these were answers to the questions of what's the most number of drinks you've ever had in one night? Somebody said a bottle. I have no idea how many drinks that is, so this is what we got. But as you can see, it's a pretty big range going from 0 to 36. You can still look at this graph, though, and get some sense for what's going on. So you can see that there's a good number of people who had answers that were at all these different values. But what happens when you really have a lot of different observations that a variable can take on? This is a frequency distribution from a survey I did a while ago of police officers, and I asked them how many years they'd been a police officer. So the answers range from 0 to 50. Now when you look at this frequency distribution, you might as well be looking at the raw data because there's so many numbers, you can't get a quick picture of what's going on just by looking at it. And you can imagine there are some variables that have even more values than this. So some things could have hundreds or even thousands of different observations that the variable could take on, which makes a frequency distribution not that helpful. And this is where we get into something called group frequency distributions. In this case, I won't be asking you to make them or do much with them, but I will be asking you to be able to recognize them. So group frequency distributions can only be made for variables that are at interval and ratio levels of measurement. In other words, these are only for numerical variables. And what they boil down to are frequency distributions that show ranges of different numbers. And there are a couple of steps to creating them. One is that you have to decide on a bin size. The bin is the range of values that you're going to find a frequency for. And I'm going to show you an example in a second, so I'm just going to talk through the steps now. The next step is to list all the bins you've come up with. And then the final step is to list the number of observations that you have in each bin. So let's look at this drinks question again. If we wanted to find out the number of people who had had different numbers of drinks, we might look at this data and see, okay, we have 0 as a lower point, 36 as a top point. Maybe we want to see how many people have had between 0 and 10 drinks, or between 10 and 20 drinks, and so on, because that will condense the data in a helpful way. So in doing that, we would be deciding on a bin size of 10. In other words, we're going to treat 0 to 10 like a big bin, and we're going to throw any response between that into that bin and use that for our frequency distribution. And here's what it looks like. So we have 0 to 9 as our first bin, where anybody who said that they had had between 0 and 9 drinks as their most number of drinks in one night is going to be counted within that bin. And for there we have a frequency of 21, which means that on that last page we had 21 people had had between 0 and 9 drinks as the most number of drinks in one night. Same thing with 10 and 19. 17 people had maxed out at between 10 and 19 drinks per night. 4 people had maxed out at between 20 and 29 drinks per night, and only 1 person was in the 30 to 39 range. So what you can see with looking at this is that suddenly you have a much clearer picture of what's going on. You can see that most of the responses are concentrated at lower numbers of drinks, and that a few people had higher numbers of drinks. So group frequency distributions just take data that's kind of messy and noisy to look at in a frequency distribution and make it a little bit easier to look at. I've also included the percent and cumulative percent on here. I'm not going to go through it in great detail, but if you want to pause this video later and look at it, you can see that it follows all the same rules as the other ones and that you could calculate them all in the same ways. Okay, so that is going to conclude our discussion of frequency distributions for now. We have a couple of other matters of business to talk about today for showing what variables look like and organizing data. One of the things that we're going to talk about is a rate. And most of you guys have probably encountered rates before. In criminal justice especially, you hear a lot about things like the crime rate. And we're going to look at what that means and also how to calculate it. So rates are something that can only be calculated for variables that are measured at the interval and ratio levels. In other words, for variables that are numerical. And what rates do is they standardize numbers or standardize counts by adjusting for population size. And an example would be, instead of just counting the number of homicides that occur in a town, you might want to count the number of homicides per 100,000 people. And a good way to think about this is that if you have 100 homicides in a town of 1,000 people, it's very, very different than if you had 100 homicides in a town of 1,000,000 people. Which town you're safer in really, really depends on that base number of people that you have, even if you had the same total count of homicides in both places. And there are steps to calculating a rate as well. One is that you divide the total number of observations by the population size, and then you multiply by some base number. And I apologize that my little video is going to be on top of that, but it says divide the total number of observations by population size underneath it. And here we're going to jump back over to the document camera and go through some examples of how to calculate rates.